Good day, folks. Here's another video on electrostatics. It's another basic video on electrostatics. It says the diagram shows the two small identical spheres R and S, each placed on in a wooden stand. Sphere R and S carrying charge positive microcoulomb 8 microcoulomb and negative 4 microcoulomb respectively. Ignore the effect of A. Now guys, if you look at this is positively charged, that means it has lost electrons. This one is negatively charged, that means it has gained electrons. They are placed on a wooden stand. Now the question, it says explain why the sphere are placed on a wooden stand. They are placed on a wooden stand to ensure that the charges do not leak to the ground, or these wooden stand they ensure that they are insulated. So if you place them on the ground, the electron will migrate to earth. That's the reason. Now it says sphere are brought into contact and for a while and then separated by a small distance. Okay guys, when they're brought into contact, if you look at my other video, there's a transfer from negative to positive. So the electrons will move from S, which is negatively charged, to a positively charged, which is R. Now it says calculate the net charge on each sphere. When they say calculate the net charge on each sphere, guys, they mean calculate the new charge on each. So the question is the new charge on each. So it's 2.2, which means we're going to calculate the new charges. It's Q new equal to Q1 plus Q2 divided by 2, which is going to be 8 microcoulomb, which is 8 times 10 to the power 6 plus negative 4 times 10 to the power negative 6 divided by 2. The answer will be 2 times 10 to the power negative 6 coulomb. So it's positive. So each charge now, after they brought into contact, they have this new charge. Now 2.3, it says draw an electric field pattern. Now drawing an electric field pattern, guys, I'll leave that question. It's very simple, but what is important, the electric field pattern now, it's based on the new charges, which is the new charges that we just calculated. They're going to be positive both, so it's going to be positive and positive, right? It's very important because they were brought into contact and separated. Now it says now, after R and S have been in contact and separated, a third sphere T of charge of 1 microcoulomb is now placed between them, as shown in the diagram below. This is R and S with their new charges. Now they are both positive, and what is there? It's 2 microcoulomb, and this one is positive 2 microcoulomb. Now there's a third charge which is also positive as well, right? We're given the distance between them. Now it says here, draw a free body diagram showing the electrostatic force experienced by the sphere T due to R and S. Now the charge of interest here is this one, is the one that experiences the forces due to this one and this one. Now they want us to draw the free body diagram showing all the forces acting on T. So I'm going to draw it here. So it's 2.4. I'm going to draw it here. So this is represent charge T, and then we're going to look the force that R exert on T. It's going to which direction? The force that R exert on T, because R is exerting a force in this one, in that direction. They're repelling each other, so it's going to go to the right. So that's the force. This is the force of what? Of R on T. And then let's look at S on T. Also, they're both positive. They're repelling each other. This one is repelling this one in that direction, but the distance now, it's bigger than this distance. So it's going, the short is going to be, the force is going to be smaller. So it's a force of what? Doesn't look smaller. Okay, let's, yeah, let's say it's like that, doesn't matter as long as it's shorter. So it's a force of what? Of S on T, right? Okay, let's go to the 2.5. It says calculate the net electrostatic force experienced by T due to R and S. So we're calculating these forces, and then we add them. So it's 2.5. So we're going to calculate the force of what? Of S on T. K Q 1 Q2 over R square. So K, it's 9 times 10 to the power 9, and then it's S on T, so it's going to be 1 times 10 to the power negative 6 times 2 times 10 to the power negative 6, and then we divide by 0.2. Where do we get the 0.2? We are doing the force between S and T, right? This is 2 microcoulomb and this is 1 microcoulomb, and the distance is 20 centimeter. You divide by 100 is going to be 0.2, and then don't forget to square. So the answer there, it will be 0.45 newtons. And then the direction of ST, remember it's going to the left, right? It's going to the left. Very important direction there. Now we're calculating the force. Now the force of what? Of R on T. It's going to be 9 times 10 to the power 9, and then it's S on T. It's S on T. It's R on T. So R is 2 times 10 to the power negative 6, and T, it's 1 times 10 to the power negative 6. We divide by the distance, it's 10, so it's going to be 0.1. It's 10 centimeter. When we divide by 100, is going to be that, and then the answer there, it's going to be 1.8 newtons, and the direction is going to the R on T is going to the right. And then the F net is equal to force of S on T plus the force of R on T, right? And then we add them. The S on T, it's 0.45, and its left, it's going to be negative, plus, and 1.8 right, it's going to be positive. And then your answer there, it will be 1.35 if you punch that in the calculator, and then your answer is going to go to the right. It's going to go to the right. It's going to be towards the sphere S, so the net. So now the question now, it says 2.6, define electric field at a point. Guys, when we talk about the electric field at a point, we define that according to exam guideline 7.6. An electric field at a point, it's a force experienced per unit positive charge placed at that point. Right, that's the definition of that. I'm not going to dwell on that. On 2.7, this is 2.6, and 2.7, it says calculate the magnitude of net electric field at that location T due to R and S. Guys, what is needed in this question is to calculate the net electric field that is experienced by T due to S and R. Guys, now it's going to be easy now that we know the net force, right? Because we use the formula that says E is equal to force divided by Q, right? Because we know the force, the net force, so this question requires the net electric field, but we're going to use the net electric, the net electrostatic force. So we do have this one and we have this one, we're looking for that. So there's no need for us to do the net from the beginning. So we're going to say 1.35 divided by the charge. What is the charge Q? Is the charge which is going to be T now. It's going to be T. We're going to use the charge of T, the net electric field that is experienced by T. So T, it's 1 times 10 to the power negative 6. So when you punch that in the calculator, that is 1,35 times 10 to the power 6 newtons per coulomb, right? That's very important, guys. So it's a net electric field strength that is experienced by T due to R and S. I hope you understand, guys. Cheers, bye.